Hungarian algorithm, I taught you that yesterday. This is the second half of this whole topic. But Hungarian algorithm, by default, minimizes. It finds the smallest total. To find the maximum optimal assignment, we do one extra step on top of yesterday. What do? We invert the starting matrix. After you've inverted the starting matrix, it's like flipping it. Then we just do Hungarian algorithm as normal, but we do it to the inverted matrix, and that you will get the maximum. So, how do I invert a starting matrix? This is literally the only notes that you need, and the example. How do I invert it? Identify the largest number in the matrix. Once you've done that, you subtract all the numbers in the matrix from that largest number, and what you'll find is you get the inverted starting matrix. What does that mean? It means the largest number will now be the smallest, and the smallest number will now be the largest. Can you get that box down, please? Also, if you've been doing your exercises, you'll notice that there's very few questions there. So I don't want to use any of your exercises as examples. So I'm going to use the same swim team, but we're going to pretend that we want the slowest team. And because it's 2024 and everyone needs to feel like a winner, the coach of the team was asked to run the slowest swimmers. That's my reasoning for us to get the slowest team. To give one of the other loser teams the chance to win something, however meaningless it would be. Get the box down and the example, please. It's the same matrix as yesterday. Don't talk yet. Can you get the examples, please? Send it. Is that what the kids say these days? Send it? Send it? It's like sending it by the mail? Send it. Yes. So the little box, how to invert, and my little meme example there. It's really going to test us, subtraction in your head, because you have no calculator. No calculator for this test? In the exam, you will. Like I said yesterday, I'm not a fan of subtraction either. So the way I do subtraction is you go from the small number and add. It's just easier to work. I'll try to demonstrate that today. It's a good opportunity for us to practice Hungarian algorithm again. All right, let me get started and then you can chat because this one's quite quick. So again, I want to reuse the same matrix as before so that you've got as many practices from the book as possible. And we're going to pretend that we want the slowest swim team, not the fastest, because this team's been dominating and they want to let someone else have a go. So use the Hungarian algorithm to find the maximal assignment to fill the slowest possible team. This is the same matrix as yesterday. What is the biggest number? I've underlined it there, 67. I want to invert it because I want to maximize. So I like to write that I'm inverting here. 67 take 56. The way I would think of it is 56 plus 10 would be 66, plus 1 is 67, so that should be 11. If that's the way that you like to handle subtraction, go ahead. I find it easy to think about addition, but if you're legendary at subtraction, do that too. 67 take 59. Is it? I'm trusting you. 67 take 52. 67 and 53. Is it? You went the wrong way. Hey. Sheep. He said sheep. 67 take 62. This is closer, so it should be easy. 5. 67 take itself. Nothing. 67 take 59. We already did that. 8. It's up the top. 67 take 49. These are the nasty ones. So me, I would go 49, 59, 69 is 20, and then go down by 2 to make it 18. And that's how I would personally do it. 67 take 55. No, not quite 2. 12, wouldn't it? Take your time. 67 take 64, 3. 67 take 58. 9. 67 take 51. 67 take 58. 67 take 67. 67 take 54. 67 take 48. That's a far one. 48. 19. Shh. I have now inverted the matrix. Like I said, please notice, this used to be the biggest number in the inverted matrix. What is it now? Is it still the biggest number? It's the smallest now. Now we do Hungarian algorithm. I taught that to you yesterday. What do? Do I do columns first or do I do rows? Rows. You subtract the what from each row? Minimum. So I'm taking 8 from the top one. I'm taking 0 from the second. Taking 3 from the third. Taking 9 from the fourth. Oh, good. I would say I was just testing you if I was a weaker teacher, but I'm not. I just made a mistake. Take 7. 11 take 8. 3. 8 take 8. 0. 15 take 8. That's 7. 6. I'm not taking anything, so it's going to stay the same. Take 3. 9. 0. 6. 13. 2. 0. 6. 12. What's the second step of Hungarian? I've done the rows. What columns? Take 2. Take nothing. Take 6. Take 6. 3 take 2, 1. 5 take 2, 3. 9 take 2, 7. 2 take 2, 0. This column will remain unchanged. 7 take 6, 1. 8 take 6, 2. 6 takes 6, 0. 6 takes 6, 0. 0, 12, 7, 6. Noughts and crosses. Do I want the least number of zeros covered or do I want the most? How many zeros can I hit to maximize to start off with? 4. I can hit 4 vertically. What's the next most I can hit? 3 along the bottom. And then I've got 2 more. And there's options there. I like horizontal, so I go like that, but you could have done it this way. I completely missed that 0. And I can hit the last 2 there. How many lines did that take? 4. How many rows did I have? 4. So I'm done. I don't need to do that reverse returning step. So I find my pattern of lonely zeros. Is this 0 alone? I shouldn't have written that. 0 alone in its row. Alone in its column. Leave it alone. 0 alone in its row. Alone in its column. Select it. 0, alone in its row. Select it. It's alone in its row. I don't need to check the column. Alone in its row, alone in its column. Leave it. Alone in its row, alone in its column. Leave it. The next one I'm looking at is here. Is that alone in its row? No, but it's alone in its column. So by process of elimination, there's only one row, one column that I can select for the remaining 0. It is this, because there was nothing in row 3 and there was nothing in column 3. It has to be that one. And hopefully you can see when I apply this pattern to the OG, that's going to be a damn slow team. 58. They chose the longest, the slowest swimmer. 53. It's not up for debate. You know, that will be the maximized team in speed. Okay? So I'll